Hello everyone, in this session we are going to discuss elimination and we are gonna see how we can change cyclohexanol to cyclohexane. So the mechanism of elimination at this session is E1, very similar to SM1, and we are gonna protonate the hydroxyl group, and for this purpose water is gonna removed and we have formation of a carbocation. So in this process, as you may know that we are gonna remove the OH and make a double bond. So as you see, we have two carbons, alpha carbon and beta carbon. So to make alkene, we need to have to name the alpha carbon, which is attached to a leaving group, and beta carbon, which is attached to beta hydrogen. And as you see, for this process, we produce sp2 from sp3, which means we are going to produce alkene from alkane. So as you see, the reaction is dependent only to the concentration of the substrate. That's why we call E1 for this type of reaction, and it's just the dehydration of alcohol and make it to alkene. So this is the mechanism of the reaction. First of all, we have the protonation of the alkane, and then we have the water production, and at the end we have the elimination of the beta hydrogen. So at this step we are going to explain procedures of producing alkene. First of all, we are going to clamp a 25 milliliter round bottom flask, and then we are going to place 25 milliliter water inside the flask. After that, we are going to add sulfuric acid to the water. You just need to remember that we don't add water to acid, always acid to water. So after that, we are gonna wait until the mixture temperature reaches to the room temperature. Then we are gonna add 3.2 milliliter or 3 gram of cyclohexanol, and then slowly uh, add this 3 gram cyclohexane to the mixture. Then we are gonna place 3 boiling chips inside the flask, and as you see in the next slide, we are gonna uh, have a azeotropic distillation assembly. So this kind of assembly is called azeotropic. So we have a round bottom flask, a Claisen adapter, we have thermometer for the for measuring the temperature, and we have distillation head, uh, we have a condenser, and we have also at the end we need a collection of uh, the distilled alcohol and water. So we are going to use a test tube. Here again you see the schematic of the azeotropic distillation, very similar to the previous slide. So after adding the boiling chips, we are gonna heat the mixture, and we are gonna continue heating until uh, the mixture inside the round bottom flask turns to black. So at the end, we are gonna produce uh, cyclohexene, and at on the on the bottom of the test tube, we are gonna have water. Cyclohexane is gonna stay up because it is lighter and water is heavier. So we are gonna remove water from the bottom of the test tube using the pasture pipette. So to make the process of the removing water from the bottom of the test tube easier, we are going to add 1 milliliter of 10% sodium carbonate to first of all to neutralize trace of acid, and then make the water observable with changing the color. So we are gonna remove the water in the basic state from the from the bottom of the test tube with the pasture pipette. So here you see that the that the water at the bottom of the test tube becomes yellow, and on top of that we have cyclohexane. We are gonna remove the water. So to remove the aqueous sodium carbonate, we are gonna add again water to wash again and make sure we don't have any residual remaining inside the cyclohexane. So you see that we washed it, and then we have the water again on. We have 1 milliliter water bottom of the test tube. Then we are going to use the pasture pipette to remove the water, and we are going to add again anhydrous calcium chloride in order to dry the cyclohexane. So you see that we are going to add 0.5 gram anhydrous calcium chloride to remove the water and dry the cyclohexane. So maybe or may not we need to distill this the remaining of mixture. So we are, as you see, we are gonna use a simple distillation in this slide to distill again the cyclohexane and collect the distilled cyclohexane. To test the production of cyclohexane or testing for unsaturation, we can use potassium permanganate or bromine carbon. For the potassium permanganate, the color from the purple color is going to change to brown precipitate, the bottom of the test tube. And for the bromine carbon, the yellowish color is gonna, or red brown color is gonna disappear after making a reaction. So here you see the both testing method. At the beginning we have the yellowish color or red brown color, and it just disappear. And for the second one, for the permanganate, you see that some precipitate is gonna pile up bottom of the test tube. So you need to be cautious about your safety, and you need to know that the permanganate is very oxidizing agent. You need to be careful when you're handling these materials. Both bromine and permanganate are very oxidizing. You need to be cautious not to make any contact with those oxidizing materials. So at the end of our work, we are going to measure the product, and we are going to test the product with the IR and NMR, and we can also measure the efficiency of our work. Thank you for listening to my presentation.